Bueno, buenas. Vamos a seguir viendo Odin Project. Paso por acá. Y voy a ver este video. Vamos a silenciar el audio. Vamos a ver qué onda.
Hello, everyone. Thanks for coming to the sidetrack. It's awesome to see it packed out in here. Can everyone give me a stretch? That's good. I need to stretch so I look less weird. Okay. So I want to talk about the event loop and what the heck is the event loop, as in the event loop inside JavaScript. So first up, as he said, I work for And Yet, which is an awesome little dev shop / product company in the US. Look us up if you need help with real-time stuff. That's what we're good at. So about 18 months ago, I'm a paid professional JavaScript developer. I thought to myself, how does JavaScript actually work? And I wasn't entirely sure. I'd heard V8 as a term, Chrome's runtime, didn't really know what that meant, what that did. I'd heard things like single-threaded, obviously I'm using callbacks, how do callbacks work? So I kind of started a journey of reading and research and experimenting in the browser, which basically started like this, right? I kind of was like, JavaScript, what are you? And it's like, I'm a single-threaded, non-blocking, asynchronous concurrent language. Right. That's, yeah, cool. I have a call stack, an event loop, a callback queue, and some other APIs and stuff. Right. I did not do a computer science degree. I mean, these words, they're words. So, I heard of V8 and the various runtimes in different browsers, so I looked at V8 and said, do you have a call stack, an event loop, a callback queue, and some other APIs and stuff? I have a call stack and a heap. I don't know what those other things are. Okay, interesting. So basically 18 months pass. We're 18 months later now, and I think I get this. And so this is what I want to share with you today. So hopefully this will be useful if you're relatively new to JavaScript, help you understand why JavaScript is so weird when you compare it to other languages you might have used, why callbacks are a thing, which cause us hell but are required, and also if you're an experienced JavaScript developer, hopefully give you some kind of fresh insights into how the runtime that you're using every day works so that you can kind of think about it a little better. So if we look at the JavaScript runtime itself, like V8, for example, which is the runtime inside Chrome, this is a simplified view, really, of what the JavaScript runtime is. It's a heap, which is, we don't need to worry about that. It's kind of boring. It's just where memory allocation happens. And then there's the call stack, which is where your stack frames are and all that kind of stuff. But if you clone the V8 code base and grep for things like set timeout or DOM or XML HTTP request, they're not in there. They don't exist in V8, which was kind of a surprise to me, right? Set timeout's one of those first things you use in JavaScript when you start thinking about async stuff, and it's not in the V8 source? Interesting. So over this 18 months of discovery, I've come to realize that this is really the bigger picture, and this is what I'm hoping to get you all kind of on board with today and understand what these pieces are. So we have the V8 runtime, but then we have these things called web APIs, which are extra things that the browser provides. So the DOM, AJAX, set timeout, things like that. Then we have this mythical event loop and the callback queue. I'm sure you've heard some of these terms before, but maybe don't quite understand how these pieces pull together. So I'm going to start from the beginning. Some of this will be new to, or the words might be new to people. Other people might get this, but we're going to quickly kind of move on from here. So bear with me if this is obvious, but I think for a lot of people it's not. So JavaScript is a single-threaded programming language, single-threaded runtime, which means it has a single call stack. And it can do one thing at a time. Like, that's what a single thread means, is like the program can run one piece of code at a time. So let's try and visualize that, just to to get our heads around what that means. So if I have some code like this on your left, we've got a few functions, a function multiply, which multiplies two numbers, square, which calls multiply with that, the same number twice, a function which prints the square of a number by calling square and then calling console.log. And then at the bottom of our file, we actually run print square, right? This code, all good? Make sense? Cool. So if we run this, well, I should back up a step, sorry. So the call stack is basically, it's a data structure which records basically where in the program we are. So if we step into a function, we push something onto the stack. If we return from a function, we pop off the top of the stack. That's all the stack can do. We push stuff on the top, pop off the top. So if we run this file, well, there's kind of a main function, right, like the file itself. So we push that onto the stack. Then we have some function definitions. They're just like defining the state of the world. And then finally, we get to print square, right? So print square is a function call, so we push that onto the stack. And immediately inside print square, we're going to call square, which we're going to push onto the stack, which calls multiply. And now we hit a return statement, right? We multiply A and B, and we return. So I said, when we return, we pop something off the stack. So pop, multiply off the stack, return into square, return into print square, console.log. Print square is now, there's no return, but it's implicit because we got to the end of the function, and we're done, right? So that is like a visualization of the call stack. Does that make sense? Yes, well, OK, great. So even if you haven't really thought about or visualized the call stack before, you've undoubtedly come across it when you've been doing certainly browser-side development. So if we have code like this, a function baz, which calls bar, which calls foo, which throws an error, then if we run this in Chrome, we see something like this in the DevTools, right? Uncall error oops. And it prints the stack trace. That is the stack trace, right? The state of the stack when that error happened. So uncall error oops, which was called in foo, which was called by bar, which was called by baz, which is called by this anonymous function, which is our main, right? Equally, if you've heard the term like blowing the stack, then this is an example of that, right? Have a function foo which calls foo. So what's going to happen? Well, we run main, we call foo, which calls foo, which calls foo, which calls foo, and ultimately Chrome says, well, you probably didn't mean to call foo 16,000 times recursively, so I'll just like kill things for you, and you can figure out where your bug lies, right? So although I may be representing a new kind of side of the call stack, you've probably got some sense of it in your development practice already. So the big question then comes is like, what happens when things are slow? So we talk about blocking and blocking behavior, and blocking, there's no strict definition of what is and isn't blocking. Really, it's just code that is slow, right? So console.log is not very slow. Doing a while loop from 1 to 10 billion is kind of slow. Doing image processing is slow. Network requests are slow. So things which are slow and on that stack are what blocking means. So here's a little example. So let's say we have, this is like a fake bit of code. Get synchronous, right? Like jQuery's like AJAX request. What would happen if those were synchronous requests? So forget what we know about async callbacks. They're synchronous. So if we just go through it like we have been, we call get sync, and then we wait, right? Because we're doing network requests. Networks relative to computers are very, very slow. Hopefully that network request completes. We can move on, wait, move on, wait. And I mean, this network request might never finish, so yeah, I guess I'll go home. Finally, those three blocking behaviors complete, and we can clear the stack, right? So in a programming language which is single-threaded, you're not using threads like, say, Ruby, like that's what happens, right? We make a network request. We have to just wait till it's done because we have no way of handling that. So why is this actually a problem? The problem is because we are running code in browsers. So let's, why can't I, Alt-Tab? Here we go, OK. So this is just, this is Chrome. This is the code I just ran. browsers don't give us, well, they do actually give us synchronous AJAX requests, but I'm actually just faking this out with a big while loop, because while loops are synchronous. So I basically while loop for like a second or 5 seconds, I think, before continuing. So if I open up the console here, we can see what happens. So we request foo.com, and like, while this is happening, I can't do anything, right? Like, even the run button hasn't finished re-rendering the fact that I previously clicked it, because the browser is blocked. It's stuck. It can't do anything until those requests complete, and then all hell breaks loose, right? Because I did some stuff, and it figured out that I'd done it. It just couldn't actually like render it, couldn't do anything. And that's because if that call stack has things on it, and here it's got these, yeah, it's still going. We've got these synchronous requests, right? We've blocked the call stack. The browser can't do anything else. It can't render. It can't run any other code. It's stuck. Not ideal, right? If we want people to have nice fluid UIs, we can't block the stack. So how do we handle this? Well, the simplest solution we're provided with is asynchronous callbacks, right? So there are almost no blocking functions in the browser. Equally in Node, they're all made asynchronous, which basically means we run some code, give it a callback, and we run that later, right? We know what, if you've been writing JavaScript, you've seen asynchronous callbacks. But what does this actually look like? So, simple example to remind people just where we're at. Code like this, console.log hi, right? We run this at timeout, but that queues the console.log for the future somehow. So then we skip straight onto jsconf.vu, log that, and then 5 seconds later, we log there, right? Make sense? Happy? Basically, like that set timeout is doing something. So asynchronous callbacks with regards to the stack we saw before, how does this work? So let's run the code. Console.log hi, set timeout. OK, what's going to happen here? We know that console.log there doesn't run immediately. It's going to run in 5 seconds' time. We can't push that console.log onto the stack. So somehow it just disappears. We don't have like a way of describing this yet, but we'll come to it. We log jsconf.vu, clear, and then 5 seconds later, somehow, magically, console.log there appears on the stack. How does that happen? And this is basically where the event loop comes in, and concurrency, right? So I've been kind of partially lying to you and telling you that JavaScript can only do one thing at a time. That is true. JavaScript, the runtime, can only do one thing at a time. It can't make an AJAX request while you're doing other code. It can't do a set timeout while you're doing other code. The reason we can do things concurrently is that the browser is more than just the runtime. So remember this diagram. The JavaScript runtime can do one thing at a time, but the browser gives us these other things, right? It gives us these web APIs. These are effectively threads that you can't access like threads. You can just like make calls to. And those pieces of the browser are where this concurrency kicks in. If you're a backend person, this diagram looks basically identical for Node, except instead of web APIs, we have C++ APIs, right? And the threading and all that stuff is hidden from you by being run in like C++ land. OK, so now that we have this picture, let's see how this code runs in this kind of more full picture of what a browser looks like. So, same as before. Run the code, console.log hi, log hi to the console. Simple. Now we can see what happens when we call set timeout. So when we call set timeout, we pass this callback function and a delay to the set timeout call. Now set timeout is an API provided to us by the browser. Remember I said it doesn't live like in the V8 source. It's like extra stuff we get in the environment that we're running the JavaScript runtime in. So effectively, we kick off a timer, right? Like the browser kicks off a timer for you. And now it's going to handle the countdown for you, right? So that means that our set timeout call itself is now complete, so we can pop it off the stack. jsconf.vu, clear. So now we've got this timer in the web API, which 5 seconds later is going to complete. Now, the web API can't just like start modifying your code, right? It can't just like chuck stuff onto the stack when it's ready, because if it did, it would like just appear randomly in the middle of your code. So this is where the task queue or the callback queue kicks in. So basically, any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs it, right? So here we can see that now the stack is clear. There's a callback on the task queue, so the event loop runs. It says, oh, I get to do something, here. Pushes the callback back onto the stack. Now remember, the stack is like JavaScript land, right? This is back inside V8. So the callback appears on the stack and gets run, console.log there, and we're done. Does that make sense? Everyone with me? Awesome. OK, so now we can see how this works with probably one of the first encounters you would have had with async stuff, which is when, for some weird reason, someone says, oh, you have to call setTimeout0. Like, OK, you want me to run the function in 0 time. Why would I wrap it in a setTimeout? Like, the first time you come across this, if you're anything like me, you're like, OK, well, I sort of see that it's doing something, but I don't really know why. And the reason is, generally, if you're trying to defer something until the stack is clear, right? So we know, looking at this, if you've written JavaScript, that we're just going to see the same result. We're going to see hi, we're going to see JSConf.eu, and then there is going to somehow appear at the end. So running it, we can see how that happens. Console.log hi, setTimeout0. Now that's going to complete immediately and push the callback onto the queue. But remember what I said about the event loop. It has to wait until the stack is clear before it can push the callback onto the stack. So your stack is going to continue to run, right? Your main file is going to continue to run, console.log.jsconf.eu, and clear. Now that we're clear, the event loop can kick in, run your callback. So that's like an example of setTimeout0 is like deferring that execution of code for whatever reason to the end of the stack, or until the stack is clear. OK. So all these web APIs work the same way, right? If we have AJAX requests, we make an AJAX request to a URL with a callback. It just works the same way. Oops, sorry. Console.log hi, make an AJAX request. The code for running that AJAX request does not live in the JavaScript runtime. It lives in the browser as a web API. So we spin up a XHR web API with a callback and the URL. Your code can continue to run until that XHR request completes, or doesn't complete. It may never complete, but that's OK. Your stack can continue to run. Assuming it does complete, callback gets pushed onto the queue, picked up by the event loop, and it's run. Right? That's all that happens when an async call happens. OK, so let's do a crazy complicated example. So I hope this is going to work. If you hadn't kind of realized, like, this is all in Keynote. There's like, I don't know how, like 500 animation steps in this whole deck. So hopefully that, oh. Huh. Oh. So, interesting. We were given a link. Is this big enough? Can people see? OK, so basically, I wrote this talk for Skeleton.js earlier in the year, and I did it there. And then after the talk, I broke half of the slides and could not be bothered to redo all the slides, because it was a total pain in the ass in Keynote to do it. So instead, I took the much easier route of writing a tool which can visualize the JavaScript runtime at runtime. And it's called Loop. So let's just run this example, and which was kind of the example we had on the previous slide. I haven't shimmed XHR yet. It's doable. I just haven't done it. So as you can see, the code, we're going to log something. This is a simple shim around like document.add event listener. Set timeout, and we're going to do a console.log. So I'm just going to run it and see what happens. So add a DOM API, add a timeout. Timeout's going to count down. Code's going to continue to run. Pushes the callback onto the queue, which runs the console.log, and we're done. If I click on here, then it's going to trigger the web API, queue the callback for the click, and run it. If I click 100 times, we can see what happens, right? I've clicked. The click doesn't get processed immediately. The click gets pushed onto the queue, and as the queue gets processed, eventually my click is going to get dealt with, right? So I have a few more examples I want to run through here, except I don't know how to see tabs. So let's just see if I can find it. There we go. OK. So I'm just going to run through a few examples just to kind of talk about a few things that you might have run into and not kind of thought about with async APIs. So in this example, we call set timeout 4 times with a 1-second delay and run console.log high. So if we run it, we can see that we run a few timeouts, but the timeout callbacks get queued. Right? So that fourth callback, we asked for a 1-second delay, and it's still waiting. The callback hasn't run. Right? So this kind of illustrates what set timeout's actually doing. Set timeout is not a guaranteed time to execution. It's a minimum time to execution. Just like set timeout 0 doesn't run the code immediately, it runs the code next-ish sometime. Right? So in this example, I want to talk about callbacks. So depending on who you speak to and how they phrase things, callbacks can be one of two things. Callbacks can be any function that another function calls, or callbacks can be more explicitly an asynchronous callback, as in one that is going to get pushed onto the callback queue at some point in the future. So this little bit of code illustrates the difference, right? The for each method on an array, it doesn't run, it takes a function, which you could call a callback, but it's not running it asynchronously, right? It's running it within the current stack. We could define an asynchronous for each. So we could, it's going to take an array and a callback, and then for each item in the array, it's going to do a set timeout 0 with that callback, right? I guess this should actually pass in the value, but anyway. So I'm going to run it, and we can see what the difference is. So for the first block of code that runs, it's going to sit and block the stack, right, until it's complete. Whereas in the async version, OK, it's slowed down, but we're basically going to queue a bunch of callbacks, and they're going to clear, and then we can actually run through and do the console.logs. So in this example, the console.log is fast, so the benefit of doing it asynchronously isn't obvious. But let's say you're doing some slow processing on each element in the array. I think I have that shown somewhere. No, I don't. OK. So let's say, oops. So I have a delay function, which is just slow, right? It's just a slow thing. So let's say processing async. And here, processing sync. OK. Now, I'm going to turn on a thing I've just been literally hacked together this morning, which is to simulate the repaint or the render in the browser. So something I haven't touched on is how all of this interacts with rendering. I've kind of touched on it, but yeah, not really explained it. So basically, the browser is kind of constrained by what you're doing in JavaScript, right? The browser would like to repaint the screen every 16.6 milliseconds, right? 60 frames a second is our ideal. That's as fast as it will do repaints if it possibly can. But it's constrained by what you're doing in JavaScript for various reasons. So it can't actually do a render if there is code on the stack, right? It's the render kind of call is almost like a callback itself, right? It has to wait till the stack is clear. Now, the difference is that the render is given a higher priority than your callbacks. So basically, every 16 milliseconds, it's going to queue a render, and then it's going to have to wait till the stack is clear before it can actually do that render. So this render queue is just simulating a render, right? So every second, it's like, can I do a render? Yes. Can I do a render? Yes. Can I do a render? Yes. Because our code isn't doing anything now. However, if I run the code, we can see that while we're doing this slow, synchronous loop through this array, our render is blocked, right? And if our render is blocked, you can't select text on the screen. You can't click things and see the response, right? Like that example I showed earlier. In this example, OK, it's blocked while we queue up the async timeouts, but that's relatively quick. But we're kind of giving the render a chance between each element because we've queued it up asynchronously to kind of jump in there and do the render. Did that make sense? Yeah, cool. So yeah, that's just kind of, this is just like a simulation, right, of how the rendering works. But it just really shows you, like, when people say don't block the event loop, this is exactly what they're talking about. They're saying don't put shitty, slow code on the stack, because when you do that, the browser can't do what it needs to do, which is like create a nice fluid UI, right? So this is why doing things like image processing or whatever, or like animating too many things just gets kind of sluggish, right, if you're not careful about how you queue up that code. So an example of that we can see with scroll handlers. So scroll events in the DOM trigger a lot, right? Like they trigger like I presume they trigger on every frame, so like every 16 milliseconds. So if I have code like this, right, on document.scroll, animate something, or do some work. If I have this code, like as I scroll, it's just going to queue up like a ton of callbacks, right? And then it has to like go through and process all of those. And if each of the processing of those is slow, then okay, you're not blocking the stack, but you're kind of flooding the queue with events, right? So this is like just helping visualize, I guess, like what happens when you actually trigger all these callbacks. So there's ways you can like debounce that to basically say, okay, okay, we're gonna like queue up all those events, but let's only do the slow work every few seconds or until the user stops scrolling for some amount of time. Cool. So I think that's basically it. There's like a whole other talk in how the hell this works. Because basically, in running the code, like this code runs at runtime, right? And it's slowed down by, I run it through a Sprima, which is a JavaScript parser. Before and after every single statement in the code, I insert a big while loop that takes half a second. So basically just like slow motions the code. Ship it to a web worker and then do a whole bunch of stuff to like visualize what's happening while doing it at runtime, if that makes sense. So there's like a whole other talk and all of that, but I'm super excited about it and super happy to talk to anyone after about it, because I think it's...
Bien, interesante la parte de los loops. Pero bueno, es material que está de hace 8 años, no sé, de haber seguramente han corregido toda esa parte. Callbacks y promises. Creo que es bastante largo para leer. Callbacks. Bastante largo. Y promises. Bueno, eso creo que lo voy a estar haciendo mañana. Voy a estar leyendo mañana. Sí. Voy a tratar de... Mientras voy a tratar de organizar un video para mañana para el canal. Nada, voy a tratar de escribir un mini guioncito para poder hablar sobre un tema que quiero hablar. Es otro bootcamp. Y bueno, así lo puedo subir el fin de semana, si Dios quiere. Así que bueno, gracias por pasar, a los que pasaron. Y bueno, nos estamos viendo mañana. Saludos.